Hi. For every structural engineer, it is very important to develop a calculation tool because we perform multiple iteration for a design or analysis so that we reach to the economical design. Now it can be achieved through Excel program, like you can develop your own Excel sheet, or you can develop a program in any of the language like C, C++, or something like that. I will be discussing more on Python because it is very simple, very interactive, and it can be learned even if you don't have any programming background. So if you wish to install Python in your system, just type Google for Python, and you will go to a website which is called python.org, and it is very advantageous to use any open source program because it is free. You can use it commercially as well if you develop your own program. Now if you go to Python, you can download the latest version available. Now the current version is 3.7.2. You can develop the or download this for your own operating system. I have already downloaded the version and I have Python 3.7.2 in my system. Now, if you go to Python, it will already always take you to IDLE, that is the interpreter for Python. If you click there, it will take us to Python shell. Like most programming courses start with the first simple program of Hello World, we will start our civil engineering or structural engineering programming with a simple program just to determine type of the section, whether the section is under reinforced, over reinforced, because it is very important to determine the type of the section, as IS code does not allow any over reinforced sections. So let's write our first program for a singly reinforced beam. When we write a program, we shall write it in a Python script, which will go here like a new file in Python script. Now we'll stick to the commands or the functions that we need for structural engineering because the language has so many commands, and for us, very common commands or the commands that we normally come across, that only we will discuss. Let's start with the first function, which is the print function. Now if you see print function, it displays anything that you write inside the print function in a quotes. So we will ask the user to enter the value of characteristic strength of concrete in MPa. This will display this message on the screen that the user has to give us the input of characteristic strength of concrete. Now we will have to assign a variable to whatever user will give us as an input. Now there are two types of variables, one mainly the two types, one is the float and the other one is integer. Let's name the variable for characteristic strength of concrete as FCK, as we always do it in our any of the design codes. As we are asking user for the input, we will assign the input as a float variable, because if you understand, float is a variable which has decimal points, whereas integer is a variable which does not have any decimal points. Now as we asked the user for the input, now the input is assigned a variable of FCK. Now let's ask the user for the second information, that will be characteristic strength of steel. So I will copy this and paste here and ask the user to enter the characteristic strength of steel in MPa. This will ask another input. Now that will be denoted by fy variable, and let's assign this also as a float variable. Though we may say that the variable is integer because our values will be fck equal to 20 and fy may be generally in 415, but we are preparing a general purpose tool wherein our value for fck and fy can be anything. These two are the material properties that we need. Now let's ask the user for the section properties. The section properties we need are width of the beam. So let's ask user for the width of the beam. So we'll write print, enter the value of width of beam in millimeters. So we'll do that, width of beam in mm. Now this will ask the user to give us the input for width of the beam. Now normally we keep the width of the beam as b, so we'll assign this as a variable b. Again, this is a float variable. We further need the depth of the beam, so we'll again go for print function and enter the value of depth of beam. So instead of width I shall write depth of the beam in millimeters. Now again user will give certain input which shall be assigned a float value because it may be in decimal also, and the common symbol that we use is small d. Now here you can add it as enter the value of effective depth, because there are two types of depths. So we are assigning a small d, that is commonly used for effective depth of beam. uh, the user input will be assigned a float variable so that it shall also contain decimals. Now we need area of reinforcement that is provided in the section. So we will ask the user to give a value of, or we will ask enter the area of reinforcement provided in beam in square millimeter. Area of reinforcement in square millimeter. This will ask what is the AST in the variable, so AST in the section. So we'll assign AST as a variable. Again, it can contain a decimal point, so we'll assign that variable as assign the input as float type of variable. Now we have assigned a few variables that we need for calculation like FCK, FY, B, D and AST. Now we'll have to calculate depth of neutral axis, which is normally denoted by x, and it is again a float value. So we will do calculation for this. The formula normally that we use is 0.87 into Fy. Now you have to use the same variable definition that is used for Fy, so it cannot have a capital because then it will show error. 0.87 Fy into AST, that is our first term in the numerator, which is divided by 0.36 into FCK into B. This is the calculation for neutral axis depth that is from all the inputs that is given by the user. Based on the inputs given, the computer or program will do the calculations, and now we want to find what is the value of neutral axis. So we'll write or print because we want to display the output. So we'll write here depth of neutral axis, in is, now we have to give the variable that we have. The variable for neutral axis is x, so string shall end here, and the output is the neutral axis depth, which is x, that is assigned as a variable for the depth of neutral axis. But we want our neutral axis depth to have only 3 decimal points, so we'll round this. This is the function which is used for rounding off the variable. So I wish to round off the variable x, and I just want to have 3 decimal points, so I will say x comma 3. So it will round it and print the value of x, which is the depth of the neutral axis. Now I wish to have conditional formatting of this answer because I need to decide on type of the section. So we all understand that if the depth of the neutral axis is less than the ultimate moment depth of neutral axis, that is XU limiting, then the section is called as the under reinforced section, and if actual depth of neutral axis exceeds the limiting value of neutral axis, then the section is called as the over reinforced section. To identify this, now we are having FE415 grade, so for that the XU limiting is 0.479 times D. Now I wish to check my depth that is calculated by using the user inputs. If x is less than 0.479 times d, we shall have the section which is the under reinforced section. So now we'll ask if our x is less than 0.479 times d, we shall ask the program to print that the section is under reinforced. If this is not true, then we'll have else condition which will give us the other value. So if this criteria is not met, we'll ask the program to print that the section is over reinforced. So we'll copy this and let's say if this works. So I will change this under to over and let's save this as a Python file or Python script. Now I will save this on the desktop as singly reinforced beam, and we will try to execute the same. So if you go to file run option, we can run this module. So let's start running this. Now, as expected, the computer program is asking us to enter the value of characteristic strength of concrete and MPa. Let's give the input as 20 Newton per mm square. Now it is asking for the characteristic strength of steel in MPa. Let's go for 415 because we have programmed it for 415. Now, what is the width of the beam? That is, let's say 230 mm. Now the programming asking us for effective depth of beam. Let's say 500 mm. Now it is asking us the area of reinforcement. Let's say some random value will give 1256.36 mm square. Now the program shall do calculations and give us and return us the type of the section. Let's see if it works. Now if you see the calculations, the depth of the neutral axis in mm is 273.918. This is because we had given 3 decimal points and he is checking also the section and he is telling us the section is over reinforced. Let's rerun the program with different values so that if we can get a under reinforced section also. So let's go again to file and open a file that we have just now created, or the program that we had, which is a singly reinforced beam. Let's open this and let's run it again. Now again it is asking us for the characteristic strength of concrete. Let's again give as 20, then strength of steel, which is 415 because the program is for 415. Width of beam, let's say 230 mm. Effective depth of beam. Now let's give higher value because then our neutral axis depth can be lesser than the ultimate neutral axis depth. Now we'll reduce the area of reinforcement also. Let's give randomly 600 or rather let's go for 800.5 or 46 mm square. And now if you check, the depth of neutral axis is just 174.521 and the section is under reinforced. So with the simple code we could understand, or we could get type of the section, which is very simple. Now again we'll go to a code just to understand it in a better way. This is the code. First of all, we went to print function and we are asking user inputs. We will assign each input as a variable and a common variable that is used in structural design, and every variable is assigned a float value so that it becomes a general purpose program. And there is a simple calculation for depth of neutral axis, and we are printing whatever is the depth of neutral axis. This is very important because Python has its own precision, but we want our value of neutral axis at the most to 3 digits, and just we are comparing this with an if else statement. If x is the actual depth of neutral axis is less than the ultimate depth of neutral axis, the section shall be under reinforced, otherwise the section shall be over reinforced. This is just the first video for starting the Python programming, and many more are going to come. Hope you like the video and please subscribe. Thanks for watching. Have a good day.